Okay, hey guys, I want to talk to you today about a little more about solving quadratic equations. So this is similar to stuff we've been seeing the last few days. Um, and maybe our first thought would be to try to factor this, and I could like set up some factors. That's how we've been doing all the other ones. But if we look at this and trying to find factors of 2, negative 2, that add up to 6, our only options are 1 and 2. And there's no way we can get that to add up to 6. So this is something that can't actually be solved by factoring. So we need another method. And this is something we talked about a couple years ago in Algebra 1, but I want to make sure I go over it again to make sure we avoid mistakes, and that is something called quadratic formula. So what is quadratic formula? Well, it's this formula that works for solving any equation that has a degree of 2. We call it quadratic equation. And so before we talk about the formula, we have to understand like the context for it. So we say given any quadratic equation, we call the coefficient of the x squared term a, and the coefficient of the x term b, and the coefficient the constant term at the end c. And so given those values, it turns out that the x values that solve all quadratic equations fits this formula right here, which says x is equal to the opposite of b divided by 2 times a, plus and minus, because there are two solutions, so that plus and minus literally means you're going to add it one time and subtract it the other, the square root of b squared minus 4ac, also over 2a. I've also written this a second way. You may have seen it this way instead, where it's one big fraction instead of two separate fractions being added or subtracted. You can do either one, whatever you're comfortable with. I think that this top way, considering it is two different fractions, is a little easier to avoid some mistakes and some common pitfalls to solving this. But I don't want to talk too much about it. I know this is something you're familiar with, but I do want to go through a few examples and just make sure we know some sticking points and know how to use this properly. Okay, so let's look back at this first example we started with. Based on what quadratic formula says, let's talk about what a and b and c should equal. So a is the coefficient of x squared. If there's not a number there, we know it's 1. B is 6 right here, so b is 6. And c is negative 2. Make sure we understand that the sign in front of each of these terms is attached to the coefficient. So once I know what those values are, I'm going to go ahead and plug into the quadratic formula, which I'll pull up real quickly. Okay, so we know that x is equal to negative b, the opposite of b. So since b is 6, I'm going to write negative 6 divided by 2 times a. So 2 times my a is 1, plus or minus the square root of b squared, which in this case would be 6 squared, minus 4 times a, I'll just put them in parentheses, times c, which is negative 2. And again, all of this is divided by 2 times a. Okay, so that's how we set it up, and it's just a matter of simplifying this to get our final answer. So we would have negative 6 divided by 2, because 2 times 1 is 2, plus or minus the square root of 6 squared is 36, and we have minus 4 times 1 times negative 2. So this is really important that we catch this. We have a negative c, and we're basically saying we're subtracting 4 times 1 is 4, times negative 2 is negative 8. So we are subtracting a negative 8, and this is being divided by 2 times 1, which is 2. So to finish this, just to clean it up a little bit, negative 6 over 2 is negative 3. And when we subtract a negative, anytime you have a negative here and here, it turns into plus. And 36 plus 8, right? If I turn this to an addition, 36 plus 8 is 44. And so we could say that our final answer here is negative 3 plus or minus the square root of 44 over 2. This can be simplified, but I don't even want to get into that right now. But I do want to make sure we understand that what this really means is that we have two solutions to this equation, which makes sense because we have a quadratic. There should be two answers. And those two answers, if I write them separately, are -3 plus the square root of 44 divided by 2 and -3 minus the square root of 44 over 2. These are two separate answers, and I think a lot of people don't understand what that plus and minus sign really means. That's what it means. So I want to take a look at one more example and just notice a couple differences. So here's another example. We want to solve the equation 3x squared minus 10x plus 3 equals 0. So again, we're looking for, this is A, 3 is A, -10 is B, and 3 is C. So when I say x equals the opposite of B, if B is already a negative number, right? So we know, so I should write this over here. If A is 3 and B is -10 and C is 3, then the opposite of B means negative of -10, which is +10. And this is divided by 2 times 3, okay? And then we have plus or minus the square root of -10 squared minus 4 times 3 times 3, because that's my A and that's my C. This is all over 2 times A, which is 2 times 3. So moving forward, 2 times 3 is 6. We have 10 over 6 plus or minus -10 squared. So remember this. When you square a negative, you always get a positive. So we don't even have to write the negative technically because it's always going to turn positive anyways, but we should have 100 minus 4 times 3 is 12, times 3 is 36, so 100 minus 36, and that's also over 6. So just to finish this up a little bit, 10 divided by 6, we have plus or minus. 100 minus 36 is 64 over 6. So I don't want to overkill with simplifying fractions and radicals, but there are, when we have the square root of a perfect square, hopefully you recognize that 64 is a perfect square. I would expect us to simplify that. So we could really say 10 over 6 plus and minus 8 over 6. And when we have fractions like this that there's no radical at the end, I'd like to make sure we can combine these together. So remember what this plus and minus means, right? It means there's literally two different answers. One of them is 10 over 6 plus 8 over 6, and the other is 10 over 6 minus 8 over 6. And those are both pretty simple to simplify, right? Because 10 plus 8 is 18 over 6, and 18 divided by 6 is 3. So one of my answers is 3. My other, 10 minus 8, is 2 over 6, and hopefully that's a fraction we can simplify and say is 1/3. So I do want to make sure we are okay with simplifying these radicals if it's a perfect square, and understanding again what that plus and minus look like. Also beware of negative b. If b is already negative, that will turn this positive. That's what I wanted to point out in this example. Let's look at just one last one and we can be done with this. Okay, so here's another one. Also has a negative value for b. So my a in this problem is 2, my b is -7, and my c looks like it's 4. Okay, but I've purposely tricked you, and I don't think I emphasized this enough in the video yet. So let me say this really clearly right now. The quadratic formula only works, if we go back and look at it, it only works if my equation is set equal to 0 at the end. Okay, so if you look at a problem like this and it says 2x squared minus 7x plus 4 and it equals something that's not 0, then what we have to do first is make it equal to 0. And how I will do that is by subtracting that 5 to both sides. And so we'll get a new equation that says 2x squared minus 7x. Those don't change. But I should have at the end not plus 4, but 4 minus 5, which is -1, equals 0. And so what this means is, yes, my a is 2, and my b is -7, but my c is actually -1, not 4. Okay, and so now that we have that straightened out, that's a easy trick for test makers to throw on a test, an ACT or whatever, so maybe just my test. So beware of that. So now the rest should be pretty straightforward. I know that x should equal the opposite of b, Since b is negative 7, I should write positive 7 over 2 times a, which is also 2, plus or minus the square root of 7 squared minus 4 times 2 times negative 1. So let's make sure we take care of that properly again. Over 2 times 2. So as I simplify, 2 times 2 is 4, so I have 7 over 4 plus or minus the square root of 7 squared is 49. And again, we have minus a negative. And if I subtract negative 8, it becomes plus 8 over 4, which gives me 7/4 plus or minus the square root of 49 plus 8 is 57 over 4. So this is my final answer. I am okay with you leaving your answer like this, but I also I'm going to continue to stress this. I really want to make sure we understand that what this really means, even though I'll let you write your answer in this way, is what it really means is there are two separate numbers. One is 7 over 4 plus this number, and the other is 7 over 4 minus this number. If we plug those in our calculators, they would be very different values, okay? And in the next couple of days, we're going to talk about what these values mean graphically, and what if I were to try to graph this equation. But for right now, I just want to practice the skill of solving these equations. I also want to point out that this formula works for all problems. If we go back at the second one we looked at, this equation actually would have factored. We could have done factoring by grouping on this, and it's totally fine if you do, but that only works some of the time. Quadratic formula works all the time, and that's why this is such a powerful thing, because it will solve all quadratics no matter what, and this is something that's going to be a big deal for us. So thanks for listening, and I'll see you in class.